All right, hi everyone. This will be my solutions to weekly contest 508. I did some upsolving and I solved the last two problems. So yeah, here we go. So first, problem one. Um, so it gives you an array nums and you have k and mo, right? Uh, first of all, you can choose to add or multiply. Okay. You want the maximum possible total sum. Well, first of all, it seems pretty obvious that we'll need the biggest numbers. So for k equals 3, then we'll use 9, 6, and 2. Now, for multiplication, what numbers will we have to multiply to get the maximum total value? Well, of course, you're going to have to multiply the bigger numbers. So you're going to have to multiply 9 times 2, and then mode decreases by 1, and then 6 times 1, and then mode decreases to 0. And at 0, you can just do 1. You can just add 1. You can do change because it won't be good to do 1 times 0. For example, over here, if k is 2, we will choose 7 and 5. Right now, mole is 4, so 7 times 4 is 28, and then it decreases by 1, and then 5 times 3 will be 15. So you add those to get 43. So that is the problem. Um, you can simply do this by sorting the numbers in nums and sorting them in decreasing order. So this way you get the k greatest. After you get the k greatest, it's just a greedy. If mo is greater than 0 right now, you can just add this to our answer and then you mo minus minus. Otherwise, you can just use the addition operation. This will always be maximum because it's always better to give bigger numbers like more, multiply them more than the numbers that are below. For example, um, always better to do 9 times 9 than 9 times 8 because we want the higher multiplication to go to the higher numbers. For example, 9 times 9 plus 8 times 9, then 9 times 8 times 8 times 9 plus. It's always better to do this first to give the higher multiplication to the higher values. Yeah. Okay, so now we'll go to problem two. Problem two is I think it's just a major implementation problem. I've seen this idea across many problems. I believe there's a similar problem in Niseko training gateway. So first off, you have to merge merge all the intervals, and then you have to separate them. So first of all, going to merging part, how would you merge these intervals? Okay, so I'll put these over here, and we'll go through them step by step. All right. First off, our first interval is 2, 6. Okay, so right now we can just add that to our list of intervals. So right now you have 2, 6. Okay. Now we get to 4, 8. Now notice 4, 8 can be merged to 2, 6 because they intersect. So all you have to do in this case is change the 6 to an 8. That way 2, 8 covers both of these. Now we get to 10, 10. Since 10, 10 is not disjoint with 2, 8, we can add 10, 10 over here. Okay. 10, 12. 10, 12 is has an intersection with 10, 10. So we can change this to 12. And then 14, 16 will going last. Okay, now notice what we did here. So first off, our initial array is 2, 6. So I will do this. Our first array is 2, 6. And then when we get to 4, 8, we change the 6 to an 8. And then after in 10, 10, we added 10, 10. And then over here, once we get to 10, 12, we can change the last 10 to a 12. And then finally, we get to this point. So what we did, first off, we started with the first interval. And then for every interval, we check if it intersects. If it intersects, then we can just change the last value to the current right range. Otherwise, we can just add it to the end of our array. And no, another thing, the L intervals, they have to be in increasing order or else it won't work. For example, if you put 14, 16 here, um, if you put 14, 16, let's see. If you put 4, 8 over here, then it won't, then the algorithm will break. So you have to first sort them in increasing order first. Okay. So what I did, so I sort them. Um, just to no, okay. Yeah. Okay, so I sort them first. And then this is my updated range, or I could say merge intervals. So merge intervals. Okay. Um, so first at the beginning we have the first range. For every value in it, if we check if it intersects. So what does it mean for it to intersect? So for it to intersect. Um Here, all we have to do is actually, so right now, let's say over here, let's say compare 2, 6 and 4, 8, okay? 2, 6 and 4, 8. How do we know we intersect? So all we did was notice that 6 is greater than 4 because we know the 4 is greater than the 2. So 4 will be in between this. So then we'll have something like this. For example, let's see. 1, 2, 3, 4, 6, 7, 8, 9. Okay. Right now, 2, 6 will be like 1, 2, 3, 4, 5. Okay. And then 4, 8. 4, 8 will go here. Now we saw there was an intersection here, so they intersect. What we actually saw was that 4 is greater than 2. We already know that because we sorted them. And then we saw 6 is greater than 4 or equal to 4. Actually, it also works. So over here is intersecting. And if it's also touching, for example, if the 4 was like this, if it was like this, it would also count as intersecting. So what I did was the last element currently, so right now it's 2, 6. Back of that, the first of that is 6, and 6 plus 1 is 7. So all we need is the current L range to be less than or equal to this 7, and it will be valid. So it's just this. And then we can just merge them together by taking the maximum of their right intervals. Because if this was 4, 5, then the range will still all be to 6. It wouldn't go to 5. Okay. Otherwise, if it doesn't intersect, we can just add it. Okay. So we're done with the merging part. Now, how do we remove an interval? Now, notice that here all of these are disjoint, so we can just do them separately one by one, and it will not affect the answer. So let's see. Free start is 7 and 11. Okay, so currently the range is 7 and 11. Now let's look at the first range, 2, 8. Um, you can see that it would become 2, 6. The range will become 2, 6. And then for the second range, it will become 12, 12. And the third range will remain unchanged. Okay, so now actually we can split into some cases. Um, so let's see, 1, 2, 3, 4, 5. Okay, so let's just say free end and free start is 3, 4, 5. 3, 4, 5, 6. All right. So the first case is if it's like outside of the range, like any of these will be outside of the range, then we can just push back the current range. Now the second case, if it's intersecting, right? For example, like this or this. It has some intersection, then we'll either take the left part or the right part that is not intersecting with it. Now, the other case is if we have if um it's like this. So the range is passed over this, then still same thing. We can put the left range and the right range inside the new array. And then finally is if it's like this. So it's inside this range, and we'll skip it entirely. So that's exactly what I did over here. There's just some implementation details. I won't get too deep inside of those because they're not very interesting. So if you want to look at them, they're right here. And finally, the question tells us to sort final integrals. Okay. So yeah, that's problem two. So problem three is the one I upsolved. So first during the contest, I tried using a segment tree, but it was actually a DP. So I figured that it was probably a DP instead. So what I did here, so I have DP, I put four states in the DP. So the zero state is if it's using the multiplication. First state is using division. Second state if you can't use any more operations. So you already use all the operations you can use. So you already use a multiplication or a division at the beginning. And number three is if you haven't used any operations yet. Okay. Now first for our base case, right? For the zero for the first element in the nums array. Then right now, this uh if use multiplication on position I, just to make it more clear. So for over here, the zero element, if you use multiplication, then it has to be num zero times k. And I have to add a lung in here because it can go to 10 to the 10th power, which is greater than integer. Um, dp01 will just be num zero divided by k. dp02 is long min because right now, uh, it's always possible at the very beginning to use some operation. So I just left it as long min. It doesn't really affect anything though. Okay, and then the third case will just be num zero because we haven't used any operations yet. So currently our answer will be the maximum of all of those, right? And then after everything, we can just update our answer at each step. Now for the DP recurrence, um, okay, so for the numbers from the second all the way to n, we can find the DP for those. So DPI 0, right? If you use multiplication on this current position, it can either come from the previous one doing multiplication, or we haven't used any operations yet. So it's just the maximum of those. And then there's also a maximum. We have to take the maximum of those with zero. Because if it's negative, it is always better to restart at this position. So this is the previous plus the current change. Right, the current change would just be the same thing as right here. Okay. Uh, and then now we go to the division part. Same thing, division can come from division or no operation. So over here it's almost the same thing as this, except zero changes to one. And then you plus nums I divided by k. That's the new increment. And then dpi2, if you can't use any more operations. So it can come from um using multiplication or using division. And then you just plus nums I. So now you can't use any more operations. Okay. So it's so it's 0 and 1. And then over here, if you can't use operations, that's just the maximum of the previous can use operations, but choose not to. Max of the 0 plus the current value. And then at each step, answer is the maximum of all of those with the previous answer max. Okay. Yeah. So this problem three, it's just a DP. Yeah. Usually Leetcode mediums won't use segment tree. So I should have known that it was a DP. Uh, so now I go to Q4. Q4 actually solved like right after the contest. I was sleeping, I was thinking of this problem, and I found the solution to it. So, realized that N and power all are pretty small. So this is actually a 2D state, a 2D queue. Well, 2D positions. So position is the current node and the remaining power, and the dpij to t. So current node is I, you have j power left, and the minimum time to reach the state is t. The neutral one will just be long max because that's the maximum time. It will all the time we reach it will always be less than this if possible. If we can reach it, I mean. Okay. So t equals long max is unreachable. At the beginning, source power is zero, so it's zero time. And then q dot push is source and power. So this is just a BFS. You can use DFS too. So right now, currently, pair P, pair long P, we could Q dot front and then Q pop. Um, so current node is P dot first, and then the remaining power will be P dot second. If the cost to move from current is greater than the remaining power, you can just continue. You can't do anything. Okay. Um, okay, so and then for vector long NP, so every adjacency. Oh yeah, so we made an adjacency last beginning. So we made a adjacency list at the beginning. I forgot to say that. Um, okay. So for every adjacent node, the next node will be v0. The next time, or the new time, will be the current time plus time needed to traverse it. And the remaining power, or the new power, will be equal to the current power minus the power to traverse. If the new time is better than the previous time to reach the state, then we'll just set the state to here, and then we'll q.push to update any other nodes. So that's our BFS here. And then here we can just use a find the minimum. So min power, I just put a min power to mean power to max power to reach the minimum time. So we iterate through all of the possible powers. If DP target this current power is less than or equal to the previous minimum, then we can just update previous minimum power to the current power. And then finally, if it's unreachable, which means this is equal to long max, return -1, -1. Otherwise, we can just return the time and the max power. So yeah, that's just a BFS in this case. So that is problem 4. So yeah, this is weekly contest 508 on Leetcode. I only solved 2 problems and I didn't do really well. I got 6,000th place. Uh, I honestly probably could have solved Q5, Q3 and Q4 during the contest. Yeah, but I wasn't really in the best state, so it's that. Uh, so yeah, I hope my solutions this time were better than my other code forces one. So yeah, bye.